Hello YouTubers, my name is Anand and welcome to my another Android tutorial. In this video, I am going to explain about Android platform architecture. We will try to understand the design level structure of entire Android system. So let's start. In my previous Android tutorial video, I told you guys that Android is an open source operating system. But apart from an operating system, Android is also a stack of software components. Now what that means? That simply means software components in Android system are arranged on top of another. To understand this better, let's have a look at the arrangements of software components. The foundation of Android operating system is Linux kernel. On top of this Linux kernel, hardware abstraction layer resides. Don't worry if you do not know what these software components do. Later we will understand them in detail. For now, just try to understand the arrangements of these software components. On top of HAL or hardware abstraction layer, native C++ libraries and Android runtime comes. Then comes Java API framework and after that system applications. So the overall architecture of Android system looks like this. Let's try to understand them in detail. The foundation of Android platform is Linux kernel. Kernel is a computer program that has complete control over everything that occurs in a system. He's like a boss, he knows everything. When a user interacts with the hardware, for example when user increase the volume level, decrease the brightness or touch device screen, kernel is the one who knows it first and provide information to the other software components. In the same way, when software needs hardware to do anything, it first sends request to the kernel and then kernel communicates to the specific hardware. But here comes $1 million question. How does kernel know that user has accessed any hardware? How does kernel and hardware communicate with each other? The answer is drivers. Linux kernel hosts drivers for various hardware like Bluetooth, Wi-Fi, audio, camera, display, etc. Driver is also a computer program that controls a specific type of device. These drivers are provided by device manufacturers. They help kernel to communicate with a specific hardware. So let's understand the whole scenario once again with an example. Suppose a user touches the device screen. Using the help of driver, device screen communicates with the kernel and kernel convey the same information to the other software components. In the same way, suppose an application wants to use Bluetooth. That application will first request kernel will find the Bluetooth driver and with the help of that driver, it will communicate with Bluetooth. Apart from communicating with hardware, Linux kernel provides threading, low-level memory and power management capabilities to Android platform. Also, Linux kernel is very secure and stable. Hardware abstraction layer or in short HAL comes on top of Linux kernel. For every hardware component such as Bluetooth, camera, audio, display, there is a standard interface which defines the capabilities of hardware component. HAL exposes these standard interfaces to higher level Java API framework. HAL consists multiple library modules. Each of these library module implements an interface for a specific type of hardware component such as Bluetooth, audio or camera. Whenever there is a call to access a specific hardware component, Android system loads the library module for that hardware component. For example, if an application tries to access camera hardware, Android system loads camera library module of HAL. Native C++ libraries comes on top of HAL. Android platform provides various native C++ libraries like OpenGL for graphics, WebKit for rendering web pages and web browsers, OpenMaxAL for multimedia applications. Some of the features of these native libraries can easily accessed by higher level Java API framework provided by Android platform. Android's core system components and services like HAL are actually built from the native code, and in order to function them properly, these native libraries are required. In my previous video, I mentioned that Android provides Android SDK, software development kit, to create and build Android applications. Using SDK, you can write application code in Java programming language. But apart from SDK, Android platform also offers Android NDK, also known as Native Development Kit. Using NDK, you can write application code in C++ programming language and directly access these native C++ libraries. On the same level, another software component, Android runtime, resides, which consists core runtime libraries and ART, Android runtime. Set of core runtime libraries provide most of the features of Java language. Every Android application runs in its own process and with its own instance of ART. ART is responsible for the execution of Android applications. It was introduced in Android version 5.0 Lollipop. Prior to Lollipop, Dalvik Virtual Machine, also known as DVM, was used for the execution of Android application. Next comes Java API framework. Java API framework provides the entire feature set of Android platform. This includes all the building blocks required to create Android apps. For example, activity is one of the building block which represents a screen in Android. Some of the prominent APIs are content provider, package manager, view systems, etc. System apps comes on top of Java API framework. This layer consists all system applications like email application, SMS messaging application, camera application, etc. Third-party applications will also reside at this level with other applications. Important point to mention here is that system apps works as both apps for the user and also provide capabilities to developers which they can use from their own application. For example, if you are making a photo application and want to let user of your application to capture a photo from camera, one option is to make your own camera application from scratch, or voice option would be to use built-in camera application. Android allows that. So this is the overall design structure of Android platform. Now let's try to understand another important concept of Android, the application sandbox. In Android system, there may be multiple applications running at the same time. Android system assigns a unique user ID to each of these Android applications and runs it in a separate process. That means two Android applications cannot have the same user ID. Also in Android, system applications cannot interact with each other. For example, if application A tries to read application B's data, Android system won't allow that because both applications are in a separate process. This is known as the application sandbox. Thank you guys for watching this video. Please like, share, comment, and do not forget to subscribe my channel. I'll catch you guys on the next video. Till then, keep learning. Have a nice day.